complements. Okay, good. So x and y are complements. Having more of one increases your valuation for the other one. The more of x you have, the more y, the more you value the y. And the way to see that is you can look at the marginal utility, right? So if you look at the margin, how would we compute the marginal utility of this guy here?
The derivative?
Exactly. Right? We would take the partial derivative. So is this review for you guys? Okay. So what's the marginal utility of good x is what? What's the marginal utility of good x? Is the derivative of the utility function with respect to good x, which is what? Who can tell me what it is? So this is the function. What is it?
Gotta write it.
So this is the derivative of x over 1,000 times y to the half.
It would give me 30 seconds.
Okay, 29, 27, 26. Okay.
Negative 1,000 x to the negative second 1/2 y to the negative 1/2.
Who agrees with that? Who has a different answer? Can you name again, please?
Forced.
Forced?
Or oh shoot, dang it!
Isn't it
What is it, forced?
1/1000 y to the 1/2?
Exactly. So the way that partial derivatives work is, so the utility is a function of two variables, x and y, right? When you take the partial derivative of the utility function with respect to x, you treat everything else as a constant. So the question is, what would happen to the utility if I kept the amount of good y that I had constant, but I changed the amount of good x? And so taking this derivative here is the same as saying, take the derivative of x over 1,000 and then multiply this by y to the half. This derivative here is just, this is just x times some constant, right? The constant comes out, we just get 1 over 1,000. The derivative of x is what? What's the derivative of x? Yeah. 1, right? The derivative of x is 1. So it's just get 1 over 1,000 times y to the half. So this is the marginal utility of good x. What can you tell me about the marginal utility of good x? What happens to the marginal utility of good x if I increase the amount of good y that we have? If I have 0 good y, what is the marginal utility of x? 0. What if I have 4? What if I have 4y? What is the marginal utility of good x?
2.
Right. So the marginal utility of good x is increasing in good y. Right. So if I have a bowl of cereal, which is my good x, I put a little bit of milk in it. I get some more utility from the cereal. I put even more, I get even more utility from the cereal. I put even more, I get even more utility from the cereal. Right? So the marginal utility of good x is increasing in good y. This is why they're complements. Having more of the milk makes you enjoy the cereal. And that's the reason why we got these corners here. Okay, coming back to our third one. Who can tell me what the answer is for this guy here?
So 0.5.
Say that again?
0.5.
0.5. Who agrees? Everyone agrees. How did you get 0.5?
Well, I actually just plugged it in, but
That's right. So you have 500 divided by 1,000, right? Times 1 to the half. That's just 0.5 times 1, which is equal to 0.5. Yeah? Make sense? Okay. So what we're going to do is we're going to take a 5-minute break, and when we come back, we're going to do utility maximization. So what we've done so far is we've looked at these three different levels, right? And if we look at this budget line here, remember we had 0 to here, and we had 1,000, 0 here. And we know that the utility of this guy is 0. The utility of this guy here is also 0. But we know that there's some point in between them. This is 500. And this is 501, right? Where the utility is going to be equal to 0.5. And so these 2 points are not the maximum. And so there's some, what we call an interior point somewhere along this line that's going to maximize utility. And when we come back to the break, we're going to find out exactly what that interior point is. So let's take a 5-minute break. It's now 11:41. When we come back, it'll be 11:46, and we can get started. And I'll put my shoes back on.